Okay, so I'll go through the presentation. I'm sure you already read. Before I do that, just one important thing to keep in mind. Peter has described at the end of his presentation a great example of all kinds of reasoning failures and ways in which probabilistic inference can fail. These are very good examples. Virtually every slide in Peter's presentation has one of these failures. Okay, so but I sent a response, a written response on all of them. I don't know if you went through that or not, but if by the end of my presentation and maybe a few questions, there is still any slider that you think is still in any way valid, please do point it out and I will explain the problem, okay? Cool, so let's go. So I will start with doing just tying a few loose ends. I'm going to go pretty quickly over that. It's not that important, but just to make sure there's nothing that's left unanswered. My goal is to get as fast as possible to thinking about inference and how do we tie together all the evidence we've seen through these sessions. I don't think it's very important to delve on new evidence, but I will just make sure it's all closed. Okay, so there was a bit of a half joke that Peter used to say that we don't do fact checking because I said that's not what Rootclaim does. In case it's not obvious, the idea is that we're not a fact checking organization. We don't publish fact check reports. We of course fact check our own evidence before we put it in the model. And wherever we're not certain about something, we add uncertainty into our model around this evidence. And we do occasionally get a fact wrong. So very often, not very often, but in many of our analysis, we did have one of 10, 20 evidence pieces that turned out to be wrong. But the idea is because that's already inserted into the model, and there's the buffers and there's the uncertainty that's in the model, it never did a major change in the result. Okay, so the whole idea of Rootclaim is that if you focus on good inference, you don't need to go into every exact detail and make sure that everything is perfect. The idea is that good inference is much more important than having all the evidence and all the details and going into each of one of those. Another issue is whether B had an advantage over A. This is something a lot of the models that zoonoses claim are based on comparing lineage B and lineage A diversity and inferring spillover dates from that. In general, this is very unreliable data. The early cases are far from complete. They are manipulated by people that don't want us to know. If it was allowed, they don't want us to know that. So there are many cases, there are many reasons why B could be more diverse than A. One of them is because B has a fitness advantage. Another is just because by chance B happened to reach this gold mine of the Huanan market, which is like the perfect super spreading location in Wuhan. So it could be just by chance. He would show that A has lost to B in every geography. In the response, Peter has suggested this was due to chance of a specific mutation, 614G, arising in B. We didn't look into that. It is possible, but in any case, just the fact that B has this, for whatever reason, has grown more, that's the reason it will have more diversity. So no animal vendors tested. So one of the many pieces of evidence that point that there's no involvement of wildlife in the HSM cluster is that animal vendors are not positive, not sick, nothing, compared to other cases where we see a lot of animal vendors in SARS-1 being infected. So just to be clear, it's not only that they weren't in the cases, they were not tested positive, they're not hospitalized, no one talked about an animal vendor. In interviews, in media, nowhere was an animal vendor being mentioned. So that's many places where we could have found it. I'll skip that one, it's less important. There was the negative mahjong sample that was brought by Peter in session 1, and this was in slides that were not shared in advance, so we didn't really know sorry, what it was. So we looked a bit into it. We found the source. Something important to notice: the way it was presented in the session was cut off. There was the rest of the line has shown was about which products were sold there. So that basically hints it's a stall and not a mahjong room. So we suspected initially that this could be just one mahjong table in some stall at the back of some stall that the people that were playing. We've seen some samples that are not in stalls that do have this. So maybe it's the nearest stall. We don't know. So we're not really clear about that. In any case, the mahjong table could be anywhere. It doesn't have to be in the mahjong hall. And in addition to that, the mahjong tables have cloth on them, which is less prone to good sampling of viruses. Something that was brought up about unequal conditional probabilities. So one thing we said multiple times, and that is that when we have this, for example, this very obvious feature, this clean 12 nucleotide insertion from a non-viral source right at the most important feature of SARS-2, that is a very strong evidence for zoonosis. However, the fact that there's a protein there or a mutation in the serine before that, that's not strong evidence because it could happen the proline and the alanine, those are things that an engineer could do. We don't know why. Okay, so Peter has said this is like this is unfair. It's like shifting the goalposts. Basically, we are allowed to claim that some evidence is very strong for lab leak, but we're not allowing it to be strong for zoonosis. But just to be clear, this is just a fact about how the world works. This is probability. So just to give an illustration, imagine that you're trying to determine whether markings on a paper are random or designed. Of course, a designer can always decide to make random-looking markings. He doesn't have to do everything ordered. But randomness cannot produce an order marking. So don't need to go through the entire calculation. You can take it offline if you want. But yeah, so the idea here is that when you have a clean marking, an ordered marking, that's a very high probability that it's not random. But if you have just random, it's a small update to the posterior. So that's the way it is. This is less important, but note that this is not something that is inherently unfair to zoonosis. Zoonosis also has evidence like that. For example, if you find an ancestral virus in an animal in nature, that's pretty strong evidence for zoonosis because it's ancestral, right? It didn't come from humans to the animal. On the other hand, if we sample an animal and don't find it to have an ancestral strain, that's not strong evidence for lab leak or against zoonosis. I mean, some animals that just don't have anything. So this kind of evidence sometimes works for one side and sometimes for the other side. It's fair in that sense, right? So nothing bad about that. It's not shifting goalposts. It's just the world and probability. We were asked about the source for 9 out of 23 animal vendors infected in SARS-1. So this was a small mistake we made. We confused two studies. One of them was about animal vendors in a market, in the Shenzhen market. We had 8 out of 20, not 9 of 20 out of 23, which is basically the same. And the 9 out of 23 was not about the market, but the total number of early cases in SARS outbreak who were food handlers, right? So these are actually our cases strengthened by looking into it. We actually find 2 different sources that show how zoonosis does involve early cases with people who are related to wildlife, right? So in the market, animal vendors were 40% infected, which was much more than the others. For example, vegetable traders, only 1 out of 20. And the other thing is that the early cases of SARS were all, not all, but were 40% food handlers. And that also brings us to something that we will discuss in a few places later, and that is in zoonosis, the early cases are actually mostly restaurants, not markets, right? So this pointing to HSM as some strong evidence is not as strong as it seems, and we'll look into other problems with HSM later. Yeah, Xinfadi, we initially made a mistake of saying that 33% of market-linked cases in HSM versus 78%. It's actually 33% versus 100%. We were looking at different numbers. So in Xinfadi, all the cases were connected to the market. So again, stronger evidence for how a true market outbreak looks compared to HSM. There was a claim made about Xinfadi being closed earlier, so it's like about 2 weeks from the first infection compared to maybe 4 or 5 weeks the first infection in HSM. But again, we have cases. We have Chen, which is 2 weeks into the market outbreak, who's completely not connected to HSM. He's very far, never had anything to do with anyone or anyone related to HSM. So in that sense, they are pretty similar. So in a sense, in Xinfadi, 2 weeks after the outbreak, they didn't find any Chen. Another case we'll go into later is Conor-Reed, which completely obliterates the case. This is something we didn't realize was as strong as it is. We'll talk about it later. We were asked, like, how did the patient 0 and WFV get infected? Sharing air with infected animals, inhalation of aerosolized virus from the culture supernatant, accidental needle prick, and an animal bite are all likely ways. But important to note that in most cases, they don't know. Okay, so in many cases, they just don't know what the source was, and that's mostly because just happened in the air. There's no special event that you can point to. Yeah, SARS and SARS-2 spike 3D metal something that was mentioned. How would they identify the SARS-2 progenitor as something interesting to research at WAV? They have a few methods to do that. One is comparing SARS and SARS-2 modeling by spike by modeling its protein folding. So this study looks into them, and SARS and SARS-2 are pretty similar. You can see here. The similarity compared to others which are not similar. You can look at the scores. So in general, SARS-2 spike without the FCS is pretty similar to SARS-1, and yeah, if it's something they plan to do in diffuse, and if they did it, they would identify this as something that's worth investigating, adding an FCS under BSL2, and so on. Another thing is about whether SARS-2 without an FCS has good ACE2 binding. It does. You can look into this paper. So again, another reason why it would be filtered to for further investigation. Yeah, something about early A cases. So there is this chart. Ignore the 2 corrections. I'm going to explain them in a minute. So this is this chart that features prominently in Peter's arguments. So one thing about it. So first about this first A case, it's at 30 December. That is a mistake. So what happened that there was a family. One was December 1 and one was December 15. And then the December 1 was moved to December 30, which was probably a mistake. But even if it's, December 26. But even if it wasn't a mistake, you still need to go to the wife, which is December 15, and assume this is the first case. Okay, so that's a mistake in that. It's important because it moves the data a lot. Yeah, here you can see the patient reported fever until December. And the date they put is when he was hospitalized, which is, of course, not the onset date, is not relevant. Another thing is that A20 has it has 2 mutations, perhaps probably another one. So 3 mutations compared to ancestral A. That means it's been circulating for a while. So the A20 sample in the market is not related to anything from an animal. It's been running around, perhaps in the market, but most likely just around Wuhan, and then someone brought it into the market. So once we put those 2, we moved the familiar cluster to 15 December, which is could be earlier, but this is the earliest. This is the latest. We put A20 with its date. Again, this is the latest it would be, and 2.5 mutations. We see this whole thing just breaks apart, right? So the idea that this is the correct line, once you have these 2 points, it's obvious this is wrong. Another thing to note here is that looking at this line here, right after this line, you start to see equal A and B. Before this line, it's almost all B. And the reason is that starting about here, 26 January, that's when HSM no longer was the criteria for entering cases. Okay, so if you look at onset dates a bit earlier than that, these are the dates where there was a strong bias to the market. So there's probably a bunch of more ACE cases around here. And once you plot them, you just see that this is just one cluster. B is developed from A. It added 2 mutations. Some of the 2 mutations are in cluster A, lineage A, and some are just in lineage B, which happened to reach the market and therefore was amplified. So all of this is just one big cluster. There's no separation as claimed.
Saar, can I ask you?
Go ahead, Will.
On that slide. So I don't understand how, so let's say that there is significantly undersampled diversity of A in the period from 1215 to 115, right? That's what you would conclude. Okay. So if that's true, then it seems at most it turns the line of best fit or whatever that regression line is into something fairly flat. It seems like it doesn't, I don't understand why you don't see a diversity of A in, let's say, the period 115 to 215 after the ascertainment bias is gone, or after January 26th, the ascertainment bias is gone. Like, I don't see how the argument you just made, you would conclude
right.
that.
Just an artificial filter, because B is 2 mutations minimum, right? So it can't appear below this. That's all. And also B has been amplified by the market, so it has more diversity. Right? Is that understood? I mean, B cannot appear here, right? Because it's by definition 2 mutations, right? So these are the sequences that didn't change much from the ancestral A, and these are all the sequences that did change from ancestral A, 2 mutations or more. Some of them are called A, and some of them are called B, but they're all just A with 2 mutations, right?
Okay, I'll
2 mutations or more.
Maybe have to explore that more. I'm not sure I understand.
I was asking, sorry, when you said after this line, what was this line? January 15th? At some point you said after this line, then A and B start looking comparable.
Talking about this? So this line is supposed to show some kind of fit of the diversity and trying to show where this started. But once you understand that these 2 cases, we have very little cases of A before January 15 because of the market bias, and you see that these are 2 points that you should have. It's obvious these 2 fit the blue line, right, much more than the orange line, right? So they're all part of the same cluster. The idea that they can be separated is just based on the problem that happens in all the studies that support zoonosis. You're using very biased data from parties that have an interest to manipulate it. They're using very complex models with lots of bugs that take weeks for people to find them. All the evidence for zoonosis is this kind of stuff. Lots of complexity with lots of unreliable data. Once you look close into it, you realize it's not.
I'm just trying to understand. It sounded like you were saying if you look exclusively at data from January 15th and later, because you're claiming there's a bias.
No, that's saying you need to fix this point to be here. That was a mistake. Mm-hmm. And let's add 820 because that's another A sample we have with 2.5 mutations. We put it here. And now the whole idea that A is somehow fit to the orange line and B fits the blue line just doesn't. All you see is just that you're missing A samples. That's all you see. You see 2 clusters that are very similar, and just before January 15, you don't have enough orange points. But the ones you do have, this one, and this one, the 3 points you do have, they seem to fit the blue line just fine. You don't need to make up another line for that.
Okay, thank you.
Yeah, not too important. This is, if you want to look at, this is the source of why we said the SARS one came from Huanan. We agree it's not very strong, but it's interesting. Higher positivity rates in environmental samples near animal stalls. Okay, so something. So there's a lot of emphasis on the zoonotic side around the positivity of 629 and animal stalls in general. We just, it's important to remember basically all the zoonotic evidence is based on very noisy, unreliable data. And just, this is a bunch of stuff you can think about that could create these biases. We don't know if this happened, but just when you need to think about evaluating the probability of noisy data that is coming from humans with interests and biases, just you need to account for a lot of possible biases. So here is a few stuff you can look at. That ordering of sampling. You would go to the animal places first. You would sample more meticulously there. By the way, that's something interesting that Peter mentioned. He said that for a while the stalls were negative, but then they became positive again. And he hypothesized maybe they learned how to sample those stalls better. But that's the whole idea. They don't try to go sample the non-animal stalls better. They're very interested in the animal stalls. That's where they try to think about the ideas. So maybe they send more experienced staff there. Maybe they use better sampling and detection methods. Maybe they contaminate it because they keep going back there. So they contaminate with repeat visits. And maybe when they get a negative sample in the lab, maybe they say, just go test it again. Maybe there's something wrong. So there are all kinds of biases when you look about in biology and human processes and politics. There's so many biases that can be introduced. Claiming that this is somehow a 1 in 68 base factor is like way off. Okay, something very interesting. So when we were looking into possible biases, one thing we suddenly noticed, this is the website that shows lots of images from HSM. We suddenly noticed something very interesting. So this is 629, and if you look, this is the only place in the HSM that has a enclosed corner. Okay, all the other areas have opening into streets, which, as Peter correctly noticed, that's a ventilation source. So we have that, you have this, you have this. All of these are ventilated. But this area around 629, which had the highest environmental positivity rate, but not the highest infection and patient rate, cases rate. Okay, cases were, as you recall, were distributed all over the West Wing, and that fits what you would expect if it's just they're just infecting each other in the mahjong room, right? So if there's one person got from outside the market, brought the virus, then they started infecting each other in the mahjong room, what you expect to see is cases distributed evenly through the market, which is what you need to see. But we see the environmental samples biased towards this corner, and this is exactly the corner that's less ventilated. So let's see a few images. Here you see a very wide street. Here you see this faces outside. Same here, you see the street at the end. Here is a wide area. Same here, street. Even the mahjong room and toilets, that's here. Even that, they have a kind of an opening, right? They're still pretty enclosed, but not as bad as the other place. More streets. And this is near 629, okay? Nothing, right? This is all closed. This is a wall here and here. Okay, so this is like the cheapest area of HSM, which makes you think that makes sense. Where would you be? Where would you have the people selling wildlife with all the illegal activities and fines that Peter has found? Exactly in the cheapest area of the HSM, where you have the worst hygiene, the worst ventilation. That's where you expect it to happen, and that also connects to what we will see in a minute, which is that's also the reason HSM is a good amplifying location. For the same reason it has wildlife, because this is the place where you have the poor conditions, poor hygiene, cheap stores. It's connected. It's the same kind of population, the same kind of conditions. We'll discuss this in a minute. Eric, you asked about smallpox leaks. We looked into that. There was only one leak in 1978. The one you mentioned, another one in 2014. That was not a leak. They just found a few unregistered vials. So what they did there in 1978, they immediately quarantined all 500 contacts, vaccinated them. It's easy to quarantine the smallpox because you have a limited short-range transmission. You can also see smallpox more easily. It was also a period when there was widespread vaccination for smallpox. So overall, yeah, they were pretty swift in closing this. This is something you can do for SARS too, because the index case from the lab probably doesn't even know he got it. Yeah, there's something else. So there was a lot of discussion about whether 5 reads with raccoon dogs is significant or not compared to, in addition to all the 0 reads that we have with raccoon dogs elsewhere. So we took a quick look at what are the highest reads. All the highest reads are places where you have infected people. It doesn't mean that the wildlife stall has to have high reads, because it's possible the animal was infected weeks earlier and it deteriorated. But just to give a sense of what would look like good evidence. Good evidence is tens of thousands of reads. Okay. Again, not saying it excludes wildlife, but just gives you an idea of what would be good evidence. Yeah, so this seems to be an important point. W virus collection. So a few things to mention. One is that there are long delays between when they collect and when they publish. It's not secret viruses. This is just how they work. They collect the viruses, they go study them, and then they publish the sequences along with the studies. So, for example, the 2020 paper that Peter mentioned only covered the collections until 2016. RATG13 was collected 2013, was not published anywhere, was published under embargo 2018, and then published earlier in 2020 due to the pandemic, because they knew this is going to come out and look suspicious, so they published it early. How many other viruses they had that they not published, we don't know. We know that there were expeditions for collecting more viruses by Guangdong, GIABR, with whom we know WFV are collaborating. Who else was collecting and collaborating with WFV? We don't know, but we can't exclude anyone. This is something that Peter mentioned. He gave some good feedback on that. We can look into it. This is a bit of calculations on how many viruses should WFV have based on their, if they decided to execute the fuse themselves. Not go over the whole calculations. You can look at it later. 3,240 bats, 6 samples from each. Based on how much generated in the past, you should have, this is how many are Sebecoviruses in the past collection. You should end up with, where is it? Should end up with the hundreds of, should yield hundreds of SARS-like coronaviruses. Okay, so you can look at the calculation later. That's a quick back of the envelope. But more important than the whole calculation is, this is what the fuse is doing. The fuse is about collecting viruses until you find one that is a pandemic potential. So we need to assume they're not stupid. They know what are the collection efforts required in order to find a few candidates. Okay, so that's what the fuse did. Their effort should match that. Okay, maybe they're incompetent, 50%. Okay, so that's a probability that they don't have it. But basically, the fuse is about collecting pandemic potential viruses, adding cleavage sites, and testing them on in vitro and in vivo. That's what it is. It's supposed to work. There's no reason to think it doesn't work. Okay, so this is about HSM. HSM is basically the only evidence that zoonosis has, and that is the supposedly amazing coincidence that the early cluster is where wildlife is sold. For this purpose, we're accepting that this is the only early cluster. It's not that important. So what we did is we did in session 1 an initial analysis of why could HSM be an early cluster. What we got then, that it is quite a coincidence, but when you weigh it against all the evidence against wildlife being involved in the pandemic, the evidence is stronger than the coincidence, and therefore we can discard the coincidence. Therefore, we give a base factor of 1. Okay, that was what we did in the past. Now we looked deeper into that, and basically it's not even a big coincidence. HSM is a likely place for a respiratory virus to start in Wuhan. So a few things here. One is that it's a large market. It was supposedly, there was zoonotic supporters were trying to claim it's some small market in Wuhan. It is the largest market of its kind in central China. Okay, it's not only in Wuhan. It's a big seafood market. It has 10,000 people a day, and it's in a high density neighborhood of Wuhan. This is very important because what happens is when you need to recall that the high density has a higher growth rate early in the pandemic. That means that a few weeks into the pandemic and into the outbreak, you will have in the high density areas many more cases than in the low density areas, right? Because it's exponential. So if you have high traffic from a high density area, you have a pretty high probability of getting one infection early in the pandemic. Okay, that's a very important factor. Another factor is that you have many permanent residents. We have 1,000 employees and also on top of that some supporting staff. That is required for the virus to stay in the market. Okay, you could say, I mentioned in session 1, you can say a train is an amazing super spreading location, but okay, it doesn't stay in the train. It just super spreads there and then goes all over the town where it starts spreading at the lower rate. So if you have this location that also has the ability to bring the virus in early days and keep it in. So these are two important factors. And then once you keep it in, then you look into growth. So the market happens to have ticks all the boxes for a super spreading location. One is about temperature. This is seafood market, a lot of ice, low temperatures, a lot of areas where the virus can stay for very long periods. Low ventilation, especially in that area we showed you. That means no UV, that means less air exchange. Specifically, there are complaints about ventilation in HSM, but I think we've seen enough of that. Poor hygiene, this is a wet market, this is more of a traditional area, so hygiene issues. Organic material is important to preserve the virus for long periods. So anything, all the meat, all the water going down the drains and the floor mixed with the organic material, that's something that can keep the virus on fomites for long. So all of these factors means that once the virus, the first infection happens in the market, it will grow exponentially much faster than anywhere else in Wuhan. Okay, so once you get there, it explodes. Another factor we have is the mahjong hall. There are many mahjong halls within Wuhan, that's correct, but the market has one which the vendors go to. That's important. That's a place where they can infect each other even faster than the market itself. So Peter made a good point about how would they infect from stall to stall in the mahjong room. Study you could look into, there was this, Peter's shown a lot of studies around super spreading locations. For some reason, this didn't appear. This one shows that there was a city where 5% of cases seeded 80% of total transmission from mahjong halls. You can see it here in the graph. It's hard to see, but all these red points here, these are all mahjong rooms. So they were a major driver of the infection in that city. And we need to remember, we have lots of mentions of mahjong infections in the early days. Okay, so everyone there suspected the mahjong room as being involved. Okay, so
question. Is there an age demographic difference in mahjong players versus regular participants in the market?
So usually they say this is an older population. I assume there are young players, but generally this is a habit that's more traditional.
And how many, and I apologize for this, how many people who were confirmed to play mahjong or be in that room tested positive in the early, let's say December?
No one did that research. Okay, so we need to remember, in general, we don't have any information on early cases. This is all people trying to dig from news stories and rumors, the early case picture in Wuhan. That in itself is a major lab-leak evidence, because why don't we have serious contact tracing and research on early cases? That's because it was not, the data was not openly provided. Okay, there was no research that was openly done on early cases. So we have all these people trying to make the best of the little data there is. We don't know how many of the mahjong players were positive. We just have these stories from all over the news about mahjong being involved. Okay, so next thing we did, once we see that HSM ticked the boxes, we go back to Warby, which is supposed to be this positive evidence that HSM is the epicenter. So what did they do? They identified, so first of all, they identified 1,676 locations that are supposedly more well-trafficked than HSM. This is wrong because they're using checking data and people don't check into a seafood market, but let's run with them. Of these, they identified 430 locations that are at risk of creating a super spreading event. And they divided those to various categories. One of them is markets. So there's supposedly 70 markets more susceptible than Huanan. So we had to go one by one and check all these locations. So I won't go into all the categories, and I will focus mostly on the market, but a few things to note. Schools, they don't have high traffic. They have the permanent residents. They may have some specific factors, but they don't have a lot of incoming traffic, so they're not likely to get the first case very early. Buildings, there's all kinds of buildings there. That's very general, mostly hotels, offices there. So they don't have the density that you have at HSM. They don't have the ventilation and hygiene issues of HSM. Hospitals are not dense for hygiene reasons. They don't, and they know how to treat respiratory viruses. They take care about that. Residences, so of course people don't mix within the residence. Each one is in its own home, and they don't have high traffic coming into the residence. HSM or markets in general have all of these. Wet markets have all of these. I can go look into the building categories. Okay, next we go into the markets, which are supposed to be similar to HSM and 70 or larger. We start going through the list. And what do we have? We have department stores, we have malls, we have supermarkets, malls, wholesale, department stores. By the way, if you look, some of these are Carrefour, right? There's Walmart. I mean, these are not wet markets, right? These are very different locations. This is the summary. The only category where it somehow looks similar to HSM is the warehouses. They had a few of those there. Still very different than wet markets, right? These are just big supermarkets, right? These are a few examples. And this, to remind you, is what HSM is like, okay? So very different. So we wanted to look at it in another angle. What we did is looked for wet markets in Chinese on Google Maps. You get these 8. Sometimes you only get 3, which is HSM, Baishazhu, and something unrelated. We look at these 8. You have Huanan there, that's fine. Then you have a few other markets that are not really related. Some of them, this is an antique market. Baishazhu is very similar, and indeed it has wildlife. So if the pandemic started Baishazhu, that would be likely under both hypotheses. That they have the wildlife, they have the conditions, so it's all good. Comprehensive shopping mall. This was unclear. We couldn't figure out what is this Wuhan recycling market. This was a department store. Some images. This is the antique market. It's outdoors, not relevant in any way. This is the vegetable market. Well ventilated, not crowded. Another market, same thing. These are just big supermarkets. Okay, so we see that basically HSM of the supposed list where it's supposedly 1,676 in the list, it's actually number one or number two behind Baishizu. Okay, so it's the whole Warabi case is completely meaningless. It's just not relevant to how pandemics develop, how outbreaks develop. So another sanity check is we'll look into subsequent outbreaks in China. And China is interesting because China was maintaining COVID zero. And you need to remember that is, we look, actually I'll look into it in a minute. So we have Xinfadi we mentioned, we have Dalian, it also was a market. Kashi also had a market involved, and these are the big outbreaks. Then you have the small outbreaks, which didn't, which came from frozen food. They had the same reason as the three big ones, but they just didn't develop into outbreak because they didn't have the conditions. They were caught earlier. Same thing, smaller ones. Then late December, then you start having large outbreaks that are not related to markets, and that is probably because at this point we have the Delta strain that is much more contagious. It doesn't need all the factors, and it's kind of going out of control in China. So you don't have this very specific situation where you have COVID zero and then you start an outbreak from zero.
Sorry, can I ask? I'd like to ask two questions there. One is
perhaps give me just a minute to finish the case, and that'd be best. Okay, so again, these cases market involved. These are the latest case. So 3 of the 5 next major outbreaks all over the market. And again, remember, in SARS, it was not markets, it was restaurants. Okay, so Peter had a pretty good response to that, bringing a lot of studies with super spreader events. So here are these to remind again. As you said, some of them are similar, like food processing plants. So we looked through these. There are a few problems. So they seem to be very non-representative. They don't mention a lot of the cases we do know. And the main issue is most of these events are not the early cluster. They are just a super spreading event. So there were already lots of infections going around when this happened, right? So for example, the first one is the chiropractics in Washington. When this happened, you already had 330 confirmed cases, 39 deaths, which means 3,000 unknown cases. Okay, this is not early cluster. It's just an interesting event that they wanted to investigate because you should know that choir practices are dangerous. Yeah, so this list has total infected, right, and multiple sites. Okay, so this is not really 1,700. This is actually 100. Okay, so we divided all of those to get the average infection per site, and then you get that actually of the top 7 sites, 5 are the food processing plants. The food processing plants are mostly meat processing plants, and that's very similar to wet markets. They have all the same conditions, temperature, and everything. The difference is that they don't have the high incoming traffic. However, the largest case is a place with 6,500 workers. Okay, so the permanent residents are by themselves quite enough to be able to catch the virus early. So overall, this doesn't really detract from our case. Yeah. And then the other thing we looked at is what about markets outside China? So Latin America, they have wet markets that are similar to Asia. They are identified as enormous hubs of infection all throughout Latin America. And these two cases are, again, very interesting because both Thailand and Singapore, they had very long stretches of time with no COVID cases. And then they had outbreaks very similar. One was the seafood market, the other was the fishery port where seafood was sold, and wet markets. So again, very similar situation, 1,300, 1,200 cases after long stretches with COVID zero. So that's the main outcome we have here, is that the factor of having a high incoming traffic is important only when you don't have widespread infections. Okay, that is the factor that ensures you have the first infection early in the pandemic. That's what makes you an early cluster, right? So you get the first infection early, and then you amplify it very quickly, much faster than anywhere else. So these are the conditions that make wet markets so susceptible. Yeah, another thing is that it's also possible that once people knew how the virus behaved, they started being much more cautious in markets, in public places, where they had, where police were, monitoring masks and everything. But when you go to, a private choir practice, you don't put the mask. Okay, so as you go later into the pandemic, as you go into other strains, this whole the whole conditions kind of weaken. So it's hard to say that these later super spreading events are relevant. Yeah, and also we don't have wet markets outside East Asia and Latin America, so we don't expect to see them there. HSM had the mahjong room. Okay, ask your question, then we'll do a simulation.
Okay, that was helpful, a helpful summary for sure. So just to make sure I'm understanding right, the kind of early in the pandemic and prior to Delta, you're saying that an early super spreading event needs to be a place with large amounts of incoming traffic to capture that initial case. Once you get a higher general positivity rate and possibly some differences in Delta, that matters less. Is that a fair summary?
Yes.
Okay. And then what would you say the kind of, how much more, like if you rolled it all up together, how much more does HSM, how much likelier is that to amplify a pandemic or to be an earlier super spreading event than say a Walmart or any of those other things on the Warby list with a similar number of people? Like I'm trying to disentangle the people number from all of the factors associated, ventilation, poor surfaces, stuff like that.
Right. So the thing is that all of these are multiplying factors. So HSM could be orders of magnitude worse than these places. Okay, so you have both incoming traffic, both the large population, 1,000 people compared to, 20, 30 in a Walmart. You then have the temperature and the ventilation and the hygiene. All of these just keep multiplying your exponential factor. So, this could be huge difference after a few weeks. I can't give you a number, but it's potentially not comparable in any way. Okay, just to play a bit with numbers, this is not the model I'm committing to, just to give an idea of how such a thing would look like. Okay, so we have a lab worker infected. They start an infection chain throughout Wuhan. It gets to 128 people. When you get to that point, one of them is likely to visit HSM because that's the population, that's the visitors per day, that's the probability. You multiply, you get 10% a day, but you need to remember HSM is in a high density area, so they have more infections, so maybe 20% a day. So within a few days, when you get to these numbers, you get the first infection in HSM. So that's the first major factor differentiating HSM from other locations. It will get the first infection very early. The next thing is that it will grow very rapidly from there. There will be a lot of places that will get the first infection alongside HSM, but it will just die out there or grow slowly. So all these factors we talked about, if we say that's only a 2x exponential factor, I think it's much more, but we need to account also for cases related to HSM. So let's say 2x, that's the second major factor, the higher transmission rate, the growth rate. Just a reminder that in Xinfadi, we had within the area of the market that was in the basement and handling seafood, we had most of the infections, right? So this was 21% compared to 1.7% infection, right? So just to give a sense of how important these factors are in Xinfadi. Xinfadi was primarily a vegetable market, but 47% were seafood vendors. So again, gives you the idea of how the exponent is important. So we continue. We have the 128 to 1 cases. One of them goes. This one is the one in HSM, and now they start doubling at different rates. The market doubles at double the rate. you get to this ratio. Let's say this is the probability that you would go into a hospital and clinic and become a WHO case. These are the numbers we have. Okay, these are the 120 to 60 that WHO reports. Okay, so I'm plugging some reasonable numbers, didn't make any crazy assumptions, and you get exactly what WHO reports, which is presumably a huge bias to the market. It's not, it's just the nature of exponents. Yeah, this is showing like the importance of a higher exponential growth. Bottom line, this is not interesting evidence. Before we said, as I said, it was an interesting coincidence, but evidence against wildlife made it not interesting. Now it's not even interesting by itself. So HSM is a fairly likely location to be the first cluster. If I need to put a number around, I would say Eric asked me, so it's around 10% that when you have a new virus introduction in Wuhan, that HSM would be an early cluster. Peter has misunderstood that to mean that because I'm giving a base factor of 1, I'm assuming 100%. No, that's given the evidence. So it's 10%, but there's less than 10% that it will look like the way it did if relating to all the wildlife evidence, if it did start in the market, right? So there's a high probability that it would start, there's a 10% probability it would start the HSM unrelated to wildlife, and less than 10% that wildlife in HSM would look the way it is, okay? I mean, if we had large breeds on the cage and we have the animal vendors and everything, this is a reminder of all the things that don't work with the market. So if we didn't have all those things, I would say, okay, this is interesting evidence. So it's 10% versus 100%, 10x factor. But given the evidence, the evidence is weaker than the coincidence. So therefore, we need to assume the coincidence in both hypotheses. And therefore, the base factor is 1. So that's not 100% for HSM. It's just best explanation is a coincidence. It's the 10% coincidence. And another thing that Peter mentioned is he said that we're claiming that every flu pandemic starts in Wuhan in HSM. So no, if the first flu case in the world is in Wuhan, yeah, then 10% it will be in HSM. But if the flu started in, I don't know, in Thailand, then you will have multiple introductions in parallel coming into Wuhan, and the whole point of HSM having high traffic becomes uninteresting because there's a constant stream of viruses coming from outside into Wuhan, right? So the whole idea of being able to pick up the virus when there's so few people is the deciding factor. And also, it is possible that HSM is very, very common early cluster in flu cases. Just no one cares about that. No one investigates it. So it's possible.
Saar, we can maybe get into this in rebuttals, but I'd like to contextualize what you're saying now with the table of case counts per month that you and Yuri produced in answer to my question.
Okay.
Would that be better?
I'm behind time a bit. So let's do that later. Okay. So the only question that this model brings up is where are the early cases outside HSM, right? Because supposedly we have, so December we see the 2-to-1 ratio. We explained that, but where are the earlier cases, right? So there's a very lengthy report by Dr. Gilles de Manouf, who so like 150 pages looking at all the early cases. I'll admit I didn't read all of it, but here are the main factors he points to why there are not enough early cases outside HSM. So one is that HSM is near hospitals that have the surveillance abilities and the sequencing abilities. So they're more likely to detect the cases. In contrast, cases that are far away from the area, like Chen with the onset of 16 December, we only know about him because he had a connection in a top-tier hospital and he went there. Otherwise, he would be treated in some local clinic and no one would ever hear about this because it would just be categorized as another flu. You need to remember that we're talking about 100 COVID cases happening in parallel to hundreds of thousands of flu cases, right? The idea that somehow would have doctors noticing it in real time is not very likely. That they would just categorize it as a flu and we never hear about it. But HSM is near the city center where you have the top tier hospitals who do have the sequencing capabilities and do have the people who are trained to notice these things. Of course, we have the early January cases that won't be entered into the system if you don't have a market link. And then you have the retrospective search, but that was very limited. That was not a very heavy investigation, and they need to cover all cases all throughout the outbreak. And most of these cases were January, February, right? So they didn't have enough time to look into December cases. So that's another bias. And then he shows that there are actually November cases. And the most interesting one is Conor Reid. We'll look into it shortly. So he's a British national, which again brings us to, that's the only reason we know about him, because he's an English-speaking Chinese who could give interviews to international press. Okay, there's probably 100 like him that we never heard about, but he's the English-speaking one. So that's what we know about him. He contracted it on November 25. He went to medical treatment 11 days later. And 40 days later, he was told he tested positive. Okay, initially they didn't have the tests, but then the hospital called him to say he was positive. The symptoms he described are classic COVID. And then some talented people have geolocated where he lives. This is from a video where he gave an interview. They found the location. It's here, so it is on the south side of Wuhan, not on the north side where the market is. It's south side where the WAV is. And again, I'm saying we don't expect the cluster to be around WAV. Just noting the coincidence. And something I want to notice. So one of the reasons we didn't really look into Conor Reid initially is that because the way Peter described it in session 1 was like this. He described it as a tabloid article, when in fact you can look in YouTube and search Conor Reid Wuhan, you would see, 50 video interviews of the person, some of them with reputable sources like The Guardian. He then says that he shopped at the Huanan market, which is not what he said. He says he shopped at the fish market where he lived, which is nowhere near HSM. Peter said that his cat died from COVID, which is not what he said. He said his cat had feline coronaviruses, which is something that cats have. And he said it was a coincidence. He didn't give it too much weight. Peter said he never went to the hospital when he did go to the Zhongnan University Hospital, which is where he got the positive sample. So conclusion, Conor Reid is a confirmed November case with no connection to HSM. This by itself is strong evidence that reduces the probability that HSM was the source, right? This is very hard to explain why you have on the other side of town, 2 weeks before the first HSM case, someone that's over there. Okay, quick recap of what we did in previous sessions. We did this priors. I did 2 ways to do priors. I think this is the easiest one to understand. So yeah, the idea is you look at the probability of a lab leak happening in Wuhan, the probability of zoonosis happening in Wuhan, gave a ratio that resulted in 25%. This is how we calculated the 1.5%. Then we looked at the virus matches the activity that WAV has. We of course always looked at what is the best explanations under zoonosis, and that's what we give the factor to. We always try to find what is the best Thielman, what is the lowest probability, the highest conditional probability you can give to evidence under each hypothesis. The market was not given any weight. It actually had a 0.5%. I think that we gave it 0.5% just in the low. Again, it's not supposed to be there, but anyway. Session 2 we didn't do probabilities because it's URI, so a quick review. So we're ignoring the FCS itself because there's something that needs to cause the virus to be infectious, right? So we're saying, okay, FCS would happen in lab leak, it would happen in zoonosis, even though it's weird that it's happening in a Sabeco virus, which never have FCS, but let's grant that. The clean insert, that's a very weird thing. Again, recall, I don't know if this is something. I mean, that's something that's very human. So you see an evidence that's very strong, and as time passes and people start to talk about it less because there's nothing new to say about it, then you forget about it. But always remember how this insertion looked in the genome. You have like stretches of clean, no insertions, no deletions, one deletion at the end, no insertion, only substitutions. Near the FCS, you have a stretch of all synonymous substitution on one side, all synonymous substitutions on the other side. There's no template switching, and then you have this clean 12 nucleotide insertion. That is something that is very, very weird, and no one was able to produce an explanation for that, other than saying nature does weird things, which is fine. But at what frequency does nature does that weird thing? Okay, so so we can look at it as what's the frequency of large insertions? That's going to be way over 1000x. We can say, what is the coincidence that the only insertion would be exactly where it's most important in the FCS? That's another like few thousand x. But we don't do that. We look to Steelman. So what we do is we look for the best explanation. The best explanation is that there is some evolutionary reason why an FCS would need to arise by insertion. No one has so far been able to produce anything like that. Peter has shown a few insertions in flu that were around that related to FCS in HKU1, which was next on FCS. But you need to remember, these are viruses that have lots of insertions, and when you compare them to other viruses, it's not weird there. It's weird here. This is where it doesn't happen. So we decided to give it a 50x. As I'll discuss later, I just realized this was a mistake. So 50x is the probability, is like the 2% is probability that no one was able to find any reason for this. But even if they do find a reason at 2%, it's still not going to be 100% probability for the event. Maybe they will find a reason why it's a 10% probability and not an 0.001% probability. So this is actually a huge underestimate, but we have enough buffers, that's fine. Yeah, we look into the CGG, we try to say, so the best explanation is CGG. One CGG is random and the other is just duplication, which is also more likely given that the whole FCS is an insert. Proline, yeah, agree, not expected, but yeah, there are a few explanations, and we just don't know what's going on in the engineer's head. Same for the RA and RAR. We gave some, Yuri has gave some explanation, but these are just possibilities. We don't actually know. Okay, I'll go later about, actually I'll say it now. So one thing to remember, so in the way Peter did reductions for these was only the conditional probability, but you need to also give the same probability for nature. So nature does not have to put a proline there, right? So you need to say, what is the ratio of nature to an engineer putting a proline there? I agree nature is more likely, but that's something that Peter forgot to calculate. So we need to compare, we need to do the base factor, not the conditional probability. That's a mistake that repeats in many calculations. Yeah, as I said, you can't say any lab action is reasonable because you don't know what they have in their mind. That's what I talked about at the beginning. So here are the numbers we give. It's up to 99.9. Very quickly on the other evidence, I'm really going to pass with. It's not very important. What we're going to see here is going to see that some evidence weakly supports zoonosis, some evidence weakly supports lab leak. Overall, I suggest we just ignore all of this, and I think Peter mostly agrees. So quickly, just what do we have? No intermediate host found. You have 11 outbreaks here in China. All of them are coming from imports. Where's the intermediate host? Where's the other spillovers? It's not happening. Just to give an example of how weird it is, in SARS, you had these people in Hong Kong University going nearby to a market in Shenzhen, and they sampled 6 civets during SARS, and 4 of them were positive. Okay, and not only were they positive, they had 3 phylogenetically distinct viruses with up to 18 Look at that difference. Okay, so this is just so much different than what we see in SARS SARS-2. In SARS-2, they couldn't find any animal anywhere, and supposedly a big argument for zoonosis is that it's 2 mutations apart, right? So that's like supposedly 2 polytomies and 2 introductions and all that. As we've seen earlier, it's very shaky, but suppose we grant that. That's not what we expect to see. We expect to see 18 nucleotide difference. We need to see a lot more diversity, and that's also what we see in Mars. That's what we see in minks as they spill back and forward into humans. So, yeah. We think that despite lockdowns, we think there's very strong interest to try to find intermediate host. I mean, this is something that, especially if you're trying to reach COVID-0, you want to catch the animals, you want to kill all of them. Yeah, you don't want to. You don't want to leave them running around. Something probabilistic that's interesting to note: there's a reverse dependency between claiming that there are multiple spillovers and saying that there's no intermediate host found, right? Because if there's no intermediate host found, that means there are very few infected animals, so you won't have multiple spillovers. If you have multiple spillovers, that means multiple animals. Where are they? Why are we not finding them? But despite all that, we just take the ratio of past pandemics and give it 2 to 4. WE behavior, they did some weird stuff with Lineage 13, not that important. There was this issue about cutting their paper right before where the crazy FCS insert would be shown. Kind of weird. They took down a sample database with 8,000 samples. They said it was hacked. I agree with Peter that the fact that it went down is not that important, but why did it not go back? Okay, so you had cyber attacks. Why are you not sharing it directly with other virologists? We're in a pandemic now. What's the reason to not share it? There's the issue of WFV workers probably not behaving that suspiciously. It could be just because they don't know that a leak had happened, and also maybe a few know, but they can't tell the others. You need to not walk around. China has also had some weird behaviors. They tried to manipulate WHO, destroying samples. Took a long time for them to accept the WHO team. They didn't share information directly with them. They just fed them the information that they wanted. And that is why today we have all these weird studies based on this biased information that comes with the wrong conclusions. Having Peter Daszak there is kind of weird. He's someone who really doesn't want a lab leak to be correct. Like we talked, they did no contact tracing, no published contact tracing. Why is that? Just a reminder, this is contact tracing in SARS, and I agree with Peter that this is not perfect, but there is some work done. In Xinfadi, they traced 100% of the people. They tested 10 million citizens, right? So they know how to do it when they want. So on the zoonosis, maybe they just weren't successful for some reason. On the lab leak, they probably did it, found something they didn't like, and buried it. Always important to look into missing evidence, not only the evidence you do have, but what evidence you would expect to have, but is kind of weird that you don't have. We don't have a whistleblower. Not that it's important, but it could be very few people that are involved in this. Intelligence agencies also nothing, which is something Peter pointed to. True, but on the other hand, WAV is a civilian agency, so not sure they would be tracked that closely. No known WAV infections. So we do have the US claims. We do also have this Huanan Ling, which was suspected as being patient 0, and WAV has responded very suspiciously, giving pictures of her, photos of her, claiming that they were from a different date. And again, suspicious behavior, but not that weird. there's the issue of no published backbone, which is that's part of that's the main claim against diffuse. Is okay, so diffuse is supposed to use WAV1 or some other backbone, and this is not what we see here. So again, as discussed previously, we expect that there are more viruses in WAV, and we have Eurydagan, who actually found in sequence contamination, he found an unpublished HKU for that's not the coronavirus backbone with MERS inserts in Wuhan. Okay, so someone did have unpublished viruses and was doing gain of function of them, right? So not that weird. And again, we had the RTG13. Yeah. Won't go over all the numbers. Some of the numbers support lab leaks, some go against it. Overall, it reduces some. It reduces on the conservative, increases on the generous. Overall, it reduces from 99.9 to 99.5 because, again, it introduces uncertainty. We always try to take the uncertainty of our data into the model. We try to make it as robust as possible, so we're never caught, making a mistake that will turn our analysis from 99 to 1%. So when we have mistakes, it moves very, very little. So the explanation of how we do this robustness, we divide our analysis to the low, medium, and high scenarios. One favors lab leak, one favors zoonosis. So one, we try to be as generous as possible to each hypothesis. We merge them as 20-60-20. That gives you the final number. And looking from outside on the analysis, you will need to show combined mistakes in our analysis that combine to 100,000. And using proper methods. We'll discuss this in a minute, but you need to, using the same methods we use, which are very careful. You don't give an FCS 1 million because you choose the most unlikely way it would happen. You choose the most likely way it would happen. So you need to show a combination of factors that chosen carefully, best explanations would give you to 100,000. Then you can go below 50%. So that's what you need to see in order to vote zoonosis. Now what we're going to try to do is try to make this whole thing more intuitive, because it's a lot of numbers. It's not how people usually think, but let's see how you can think of it more intuitively. So when you do probabilistic inference, all you're trying to do is to quantify the evidence and to evaluate how much it matches human experience. Okay, human experience is statistics. We look at how often things happen in the past. We use that as a probability, and that's the probability we give to the evidence, to the new evidence. And basically, the hypothesis that requires less unusual explanations, less coincidences, that's the more likely one. That's basically all you're doing. You're looking at the past and saying, of the hypothesis offered today, which one requires the past to be less weird? Which one says that things that happened in the past, things that didn't happen in the past or happened in the low frequency of the past are the things that happen here? If you're saying, for my hypothesis to be correct, I need this and this and this coincidence, which hardly ever happens in the past, that's the one that's less likely. So what does lab leak needs to show? It needs to fight the priors, which seem to prefer zoonosis, but once you look into gain of function and the BSL2 and diffuse and everything, the whole thing breaks down. I mean, it's pretty likely that a lab leak would happen under those conditions, probably more than zoonosis. And you need to explain the market being the first array cluster. These are the only two unlikely events that lab leak needs to explain. And I think we explained them very well. Zoonosis, on the other hand, needs to explain why this is starting in Wuhan, okay, which is a 1.5% coincidence. Why do we have the first FCS ever in a subecovirus? Why this 12 anti-insertion? Why does we have the CGG that looks like this didn't come from another virus? No explanation was given by anyone other than a coincidence. all the evidence against the market. Why don't we have positive animals? What's the negative correlation? Animal vendors, all of that. All the evidence against spillover. The early genetic variance points to a quick localized jump. Okay, so it's one jump. Let's suppose we say it's 2 jumps within Wuhan within a week. That's not what we see in zoonosis. SARS-1, MERS, HIV, the spillback from minks, they all show multiple spillovers, different locations, very high genetic diversity. You need to explain that. Why did this happen in SARS-2? Why we don't have any other spillovers other than Wuhan, not by reporting or not by phylogeny. So Peter has suggested we don't have other spillovers because everyone had the SARS too, and you can't notice the spillover, but that's incorrect. First, because you would see it by the phylogeny, and second is China was in COVID-0, so you definitely need to see reports of that. Why don't we have any intermediate host? No one was able to detect that. So yeah, so now looking at on the from the complementary, what does zoonosis has? Just has a prior that is based on little experience. There are not that many pandemics that you can make statistics from, and that is already overwhelmed by a high likelihood that WLV will leak a virus like SARS-2. Okay, so they have the prior, and then they have all this supposedly dispositive evidence. I don't know if you know why this dispositive is in quotation. This was the Warby study. Initially was published claiming to be dispositive evidence for a market spillover. After review, they had to remove that claim. Anyway, so their evidence is always these complex models that tries to obscure obvious evidence. B looks like it came from A. It's very obvious, 2 mutations, nothing goes, there's nothing to say it didn't, but then you go into those complex models that's based on evidence, data that's come from a very biased source, unreliable, all kind of models with bugs and assumptions, and you just need one of these to fail, and this whole model breaks. And this is something we've seen multiple times throughout the debate. So that's the only evidence they have. Okay, the obvious evidence says lab leak, FCS, the phylogeny, the spillovers, everything says lab leak. The evidence you could actually understand that it actually is robust. In order to do the other evidence, you have these motivated researchers building complex models with lots of mistakes and bad data. That's the only evidence they have. And just to clarify, I have nothing against complex models or science. It's just that we have a lot of experience on the reliability of these things. These things are very easy to break, and that means you always need to give it the best explanation of something wrong, rather than the whatever 0.0001% p-value that they claim. It's like what we talked before. I mean, you always need to find good explanation why the study is wrong, not because they did everything right and that's just the p-value that's just happened to fall on the coincidence side of the p-value. That's not the best explanation. And the important thing is it's very suspicious when that's all the evidence you have. Okay, so if we have lots of evidence, also studies, also good evidence, robust, that's fine. But that's all the thing they have, and that's very reminiscent of UFO evidence, right? UFO evidence, no matter how many more cameras we have, we always have this one shot that you just need to move the camera in this direction. Just if they only had a bit more zoom, then we would finally have this positive evidence for UFO, but we don't have it. We always have this almost evidence. That is a clear sign that there's something wrong with the evidence, right? If all the things you have are the ones that constantly fail, all these complex models, you have a problem. Yeah, that's what we just said. Now I try when I have limits. Okay, now I'll try to do it. You know what? You can leave it later. It's not that important. I'm doing the same thing, but just looking at it chronologically, right? So we're saying like, okay, diffuser was rejected. They decided to do it. Here's the evidence that supports it. They screened the database for ACE2 matches. It's possible that they have unpublished viruses. They found a good match. We know that something is likely to happen because there are good AC matches in nature. They then added an FCS, which is exactly what they're supposed to do, and we have good evidence for that. They then maybe played with any glycans. They did all of this in BSL2. That's the evidence that they did in BSL2. And then that's very likely to result in an infection and start a chain. Then they reached the HSM. As our model says, after around 100 infections in the city, one of them will reach HSM and start the early cluster exponentially. Few people are aware of the leak, and therefore we have all this evidence of no whistleblowers, all of that. Of course, no zoonosis evidence was found because there is no host. You had many outbreaks, but none from wildlife. And then you have all this weird behavior of trying to control the data. Now we do the same for zoonosis. Yeah, so you have a bad coronavirus that happens to have good human ACE2 binding. That's fine. It acquired an FCS through this weird thing that we've never seen. No evidence why this happened. And glycan was removed due to selective pressure. That's fine, although a bit unlikely that would happen so fast. There are not that many mutations that remove N-glycans. It gets to Wuhan. We give two options. Despite the claim that HSM is involved, if we want to Steelman zoonosis, it has to be that HSM was not the source. So it got to Wuhan by some other method and then created the HSM cluster, which looks like no wildlife was involved in it. And then somehow the intermediate host was not found. So this, when you look at this chronologically, there's a lot of weird things that need to happen. The lab leak, just everything that's supposed to happen. Defuse, collecting viruses, finding one that matches, FCS, BSL2 infection, just everything that's expected to happen is exactly what you see. Another intuitive way to look at probabilistic inference is comparing parallel versus serial or versus and. Again, the same claims, just from different directions. So what you have in zoonosis is a lot of serial claims. Okay, these are arguments that all the steps in the argument needs to be true for the larger argument to be correct. While for lab leak, you have arguments that sit on multiple legs. You can knock half of them, and the argument still stands. Okay, we'll see some examples. So look at the Picard-Warburg models, right? So they need to have unbiased data collection. That is not the case. They need to have the data not filtered and manipulated. That's not the case. They need to have, then they have part one of them, all the part two of them, all the part three, whatever. They have these models that build one step upon the other. All of the parts of the model need to be without errors. That's not correct. Warburg incorrectly classified world locations to super spreader locations. We saw that that's how this is incorrect. Then Warburg assigned the 0.034 probability to finding an early A case next to the market, but they forgot that density is not a linear relation with infections. The more dense you are, the more likely, you're more than linearly likely to have an infection because it's an exponential process. So they had this assumption that this pair value is irrelevant. Then you need to show there's no bug in the code that implements the model. That's, we know for Picard, this has failed. And again, it's not that, it wasn't easy to find this bug. You need to have dedicated people working for weeks to find it. Okay, that's not easy. Just imagine how many more bugs no one has found. And by the way, both for lab leak and zoonosis models. Yeah, that's why we don't use all the lab leak models. There are plenty of nice lab leak models. We don't use them because we know they're not worth anything. And then you need to assume that the result was interpreted correctly. So yeah, Picard did this wrong. Maybe I'll talk about it later. And then you need to say that all the simple evidence that's out there is false. So all of this model can just collapses once you assume Connor is an early COVID case, or if you assume that this ProCov2 mutation is not a version of, or you need to say that China is somehow has an HSM connection. So all of these there's all this simple evidence that's easy to understand. It needs to be wrong for all this model to hold. On top of all the stages of the model, they need to be correct. What is a parallel example, an OR example? FCS. So it's the first in SARS-like viruses. It has this clean 12-2 insertion. It has the non-virus source. If you knock any one of these, it's still clearly in engineering FCS, right? Because you have parallel support for it. Okay, this is going to be tough. So the last thing I want to do is I want to talk a bit about meta-inference. So I'm suspecting that at this point, what probably is going through your heads is that there is so many details, and we need to understand all of them. And unless we understand all the details, then we can't make a decision. It's just 50-50, and that is not the case. We have found consistently that you don't need to investigate every last detail. If you have good inference methods, there are ways to reach certainty, enough certainty, at some point without verifying everything is correct. If you build enough robustness and uncertainty modeling into your own model, then it's fine. At some point, you can be confident enough. So I want to look a bit at what kind of probabilistic inference mistakes we had from the opposition here. So one is giving 10,000 for the market. That is based on it being 1 in 10,000 of traffic. That is not the best explanation. We happen to find very strong reasons why it's a base factor of 1, okay? But even if we hadn't, this is a very complex thing. This is human behavior, biology, unreliable data, politics. Claiming 1 to 10, it's so rare to be able to find a 1 in 10,000 evidence. I don't recall ever finding one in my life. So 10,000 is something you find maybe in physics if you manage to clean all your environment from all confounders, and the lasers are perfectly aligned. Then you can go and publish a study with 10,000 base factor. That's fine. This does not happen with people. There will always be some dirty example that you don't think of. So that's a very common mistake. They're basically strawmanning our explanations. We are not saying that the market is a coincidence. Therefore, 10,000 is not the best explanation. We happen to have a good explanation, but even we haven't, you don't go to 10,000. Just an example, this is what would happen if we were strawmanning FCS, right? It would say there's a million insertions and only 50, there's a million sequences and only 50 insertions. So this is the factor. And then it happened to fall exactly in S1, S2. Okay, then the probability that it would come from some non-viral source. And then we multiply all of them and you get 1 and 2 E10, right? That's just one evidence. That's what would happen if we were strawmanning Zoonosis, but that's not what we do. We say it's a 50 base factor because maybe there's something we don't understand, and like I said, that was a mistake. It has to be 500, but we give it 50. That's our position. So the more complex the issue is, and the less experienced statistics we have on it, the lower the base factors you can claim. This can never appear. And just in general, if you have a reliable 1000x factor that is not filtered from a lot of trials, you don't need probabilistic inference. That is your true hypothesis. 1000x doesn't happen by chance. Okay, you need to look a long time until you find 1000x. I mean, you can find it very easily for the true hypothesis, but finding 1000x for the wrong hypothesis, that is very rare. So once you have 1000x, you can stop researching. You don't need to do probabilistic inference. That basically puts you in the realm of the exact sciences. Okay, I did a very accurate, quantum physics experiment. This is the result I got. That's a p-value. You can claim it. Another thing is forgetting dependencies. Okay, I won't have time to go with all of these. If you want to do it in the questions. Not adjusting for filtering from multiple opportunities. Right, so this, for example, he's saying that 820 means that the lab worker went again to the market. Why? It's much more reasonable is that it was running around the city. And then when you had a lot of cases, and one of them, late December, went and deposited 820. Right? Again, this was given 2000 factor for something that's pretty much guaranteed to happen. At late December, you will have infected people coming to Wuhan, to HSM all the time. Cherry picking, so a lot of the evidence the position points to is okay, the market has A and B. That's very weird. But why are 6 out of 16 cases B and only A is an environmental sample? Only A is an environmental sample with 2, 3 mutations in late December, right? So always you need to look at all the evidence. You can't filter. Another thing is focusing, I mentioned this earlier, focusing on the low conditional probability for one hypothesis rather than the ratio between the conditional probabilities. I mentioned this before. This is, by the way, so one of the main claims for 9/11 being an inside job is that the BBC said that WTC7 has fallen before it has fallen. Okay, that's a low probability. It's not that low probability when you consider that there are like hundreds of news outlets talking and one of them will make a mistake. But the thing is, what is the probability that this would happen under an inside job? What exactly is the BBC doing in this conspiracy reporting before time? Why do we need the BBC to be involved in the conspiracy? So yeah, so sometimes things with low conditional probability happen, but there are even low conditional probability in the other hypothesis. So the base factor needs to be the one that's considered and not the conditional probability. All the calculations you saw on Peter's slides are conditional probability and not base factor. That's a major mistake that's been going on over there. And I think Eric, you pointed that in a few places. We have a few cases of double counting. In contrast, that's something we don't do. We look at all the evidence without cherry picking. We Stillman everything. We really Stillman. Don't say 50% of 100% instead of 50%. We actually go for the big numbers and make sure there's good explanations. We look for dependencies. We put a lot of buffers for our own mistakes. Yeah, okay. There's some good things I want to go through about meta-inference. Maybe if you want to ask me questions about it, we'll do that. Okay.